Often in AP Calculus AB, we get problems that say the blank is changing at a rate proportional to itself in some form. And so I'm going to give you a shortcut for being able to solve these type of problems in general when they come up in the mathematical modeling sections. So if the rate of change of something is proportional to whatever the object is, this is the differential equation that's occurring. The rate of change of y is proportional as the constant times the y. So if we isolate our variables, separate our variables, dy over y equals k dt, then we can integrate both sides, and we end up getting log y equals, let's see, kt plus a constant. As we've described in other videos, if I now e to the on both sides, I end up getting y equals e to the kt times e to the c, but that becomes a leading coefficient, and so this is just always the solution to this differential equation. And in fact, if you were to replace t with 0, then you get y equals c e to the 0, which is c. So in other words, c is your initial amount. So that is a shortcut. So whenever you get a differential equation or a modeling situation that's talking about something being proportional to itself, the rate of change being proportional to its amount, this is the solution with an initial amount of c. So let's use this on some AP style problems now. Bacteria in a certain culture increases at a rate that is proportional to the number that are present. That is literally the rate of change is proportional to the amount. And then it says that it doubles in 3 hours. So I'm now going to use all of that theory that I just did, that one solution, to say that I'm actually going to even simplify it further. Instead of doing the e to the k thing here, I'm just going to say that I know what the model is. It's exponential, right? So y is equal to whatever the initial amount is multiplied by, well, what's my multiplier here? It's doubling. And how long does it take to double? T over 3, because it takes 3 hours to double. So if I were to replace t with 3 over 3 is 1, and that represents a doubling. Question is, how long does it take to actually triple? So if I'm going to try to triple here, that means that I actually want the output to be 3p. So I'll say 3p equals p 2 to the t over 3. Divide by p, log both sides, log, and then log. And then as I try to isolate the t, that means I would have to take the ln of 3, I'd have to divide by the ln of 2, and I'd multiply by the number 3 in order to get my t. So that is the amount of time. Do I see that answer anywhere? Yes, I do. Right there. Answer choice A. I'll do the odd problems here so that way we can do the even ones in class in our small groups. So skipping ahead to 3, it says during a certain epidemic, the number of people that are infected at any time increases at a rate proportional to the number of people infected. So again, same kind of problem. When it's first discovered, there's 1,000 people infected. So it actually gave us an exact amount at the beginning. So y equals, I already know what the initial amount is, 1,000. Again, I'm going to do the same exponential trick I just did in the last problem, is that we know that there's supposed to be 1,200 7 days later. So I'm just going to take 1,200 over 1,000, and it has to be 7 days later. So that literally completes the model, right? Because we have the initial population, the multiplier, and notice if I plugged in 7, I would literally get 1 as an exponent, so it'd become 1,000 times 1,200 over 1, which is literally the amount, and we have the exponential model. So how can we figure out how many there are 12 days after the epidemic was first discovered? Replace the t with 12. 1,000, 1,200 over 1,000 to the 12 over 7, and that of course would be a calculator problem here. So 1,000 times 1,200 divided by 1,000 to the power of 12 over 7 looks to give me approximately 1367. There is the correct answer. So So it's a pretty nice shortcut, right? Let's try it on problem number 5 then. A population grows according to this differential equation, which literally says dy dt equals a constant times y. It's proportional to y. The population doubles every 10 years. Doubles every 10 years. So the model in this situation would be y equals whatever the initial population is, and then it would be doubling every 10 years. So you'd need to do a 2 times t over 10, because that's what would represent the doubling. Now, what's interesting about the way it's written now is that they're actually asking for k, the constant. So remember, like we discussed, this is the same as some initial population e to the kt. So if we look at these carefully, you'll notice that on this side, the c is just the p, right? That's the initial population, so it could be interchangeably p or c. In this expression, this is the same as writing 2 to the power of 1 over 10 to the power of t, as opposed to over here where it is c e to the k to the t. So what that means is that the 2 to the 1 over 10 is just simply equal to e to the k. So if we just want to solve for k, all we have to do is take a logarithm of both sides, and the answer is going to be log of 2 to the power of 1 over 10 is k. So again, that feels like a calculator problem. So what is the log of 2 to the power of 1 over 10? 0.0693. 0.0693. So that is the answer to problem number 5. Okay, again, doing the odd problems. So let's come down here to this free response problem. Water flows continuously from a tank that is proportional to the amount remaining. So they're giving us the same differential equation. They also told us there was initially 10,000 and at time equals 4, 8,000 was there. So this time they're actually literally asking us to solve for it, so we have to go through the steps. So dy dt, separate our variables, dy over y equals k dt, integrate both sides, antiderive, log y equals kt plus a constant, raise e to the on both sides, y equals some constant e to the kt, and then solving for the initial conditions and the k. So the initial condition was given as 10,000. So with that given information of 10,000, I'll immediately write y equals 10,000 e to the kt. And then we're told that 8,000 is remaining after 4. So 8,000 equals 10,000 e to the 4k. Divide by 10,000, no calculator, so I have to go 0.8 equals e to the 4k. Log both sides, ln 0.8 equals 4k. And so k is equal to ln 0.8 over 4. It did ask for the actual solution, so as a final answer here, if I was actually taking the test, I would say y equals, what was our initial again? 10,000 e to the log 0.8 over 4 multiplied by t. And that's the answer I would box or somehow indicate as my final answer. But then, to the nearest cubic foot, how much remains at 8 hours? Well, that's just take the equation we found and plug in the 8. So, oh, no calculator. Almost tricked me. Okay, so no calculator means we would have to say 10,000 e to the ln 0.8 over 4 times 8. Right, that's a multiply by 8. And on a no calculator section, this is completely sufficient. You just say this is the answer. Oh, but it does say to cubic feet, so it must have needed a calculator. Well, let's go see. Oh, 4 hours, 8,000. So you are going from 10,000. And then you have, oh, let's just solve this then. 8 over 4 is 2. 0.8 to the power of 2 would be, let's see, 10,000 e to the ln 0.64 There's our cancellation. So the answer is actually 6,400 cubic feet. Oh, fancy. That's pretty cool. Okay. 6,400 cubic feet. Okay. I think we have one more problem to try. Actually, two more. Let's go see if we can get these done. Okay. Consider the differential equation, this, where the solution is y equals f of x and the initial condition is 2. Which of the following statements is true? Okay. When y equals 0, this would become 0, and so f of x would have a horizontal tangent, not a vertical. If x were equal to pi over 2, 1/2 pi over 2, and cosine of pi over 2 is 0, so you would have a horizontal tangent. That's true. So very quickly, just by plugging in y equals 0 and x equals pi over 2, we get that 1 is false, 2 is true. So we still got to do the last one. The slope of the tangent at 0, 2 is equal to 1. So there we would replace x with 0 and y with 2. So 1/2 times 2 times cosine of 0. Cosine of 0 is 1, 2, 1/2. Yep, that one's true. So the answer is D, which is answer choices 2 and 3 are correct. Okay, now our last one. No calculator. Consider the differential equation dy dx equals x plus 2y for which the solution is y equals g of x. Which of the following is true about the solution that contains 0, -1? So dy dx at 0, -1 would mean replace x with 0 and y with -1. So 0 plus 2 times -1 is -2. So that means the g of x has a negative first derivative, so we are decreasing. Goodbye, goodbye. Okay, part 2 is to figure out if it's concave up or concave down. So the second derivative, which is d squared y dx squared, is the derivative of x with respect to x, which is 1, plus 2 times the derivative of y with respect to x, which is dy dx. So if I evaluate that at 0, -1, we get, notice there is no 0, or sorry, there is no x and there is no y, but there's a dy dx, 1 plus 2 times, and as we found out in the first part, the dy dx was actually equal to -2 at 0, -1. 1 minus 4 is -3, and so the second derivative is negative, meaning we are concave down. So decreasing concave down means the correct answer to this problem was answer choice D.